Okay, so today's lesson is section 1.6 day 3, and what we're going to be doing is we're going to be simplifying rational expressions. So we'll talk about what those are and how we approach these problems based on some of the things that we've already learned previously. So the first thing, just so that we can state our objective, is we're basically just going to simplify rational expressions. So, we've already probably seen some of these before, but we just don't know specifically what they are and how we can simplify them appropriately. So basically the first thing that we need to look at is a vocab term and what it means to be a rational expression. And really it's just an algebraic expression, so just some expression that has variables and numbers and a combination of those things. But basically it's just in fractional form. And so when we look at a rational function or we look at a rational expression, basically all that it's telling you is that the expression or the function is going to just be in a fraction. And so we've looked at fractions, we've worked with fractions before, so we're just going to apply those to how that works with algebraic fractions, or what we call rational expressions. So in essence, what this basically does is this is us simplifying fractions, but in a little bit different way. And so when we typically look at our algebraic fractions, or we look at anything like this, what we typically run into is we would run into a fraction 12 over 27, and I would have you reduce that, and you would say, oh, well, it reduces by a factor of 3, and it reduces by a factor of 3, so you're just left with 4 over 9. And that is not necessarily untrue, and so that's something that we've basically been able to do, is that we simplify our fractions. Now if I gave you something of this nature where you had 12x to the second over 27x, now this is where we would have a little bit of trouble, but we could use our rules of exponents to kind of split those apart and say that, well, 12 over 27 reduces to 4 over 9. But when we look at our x's, this x down here cancels one of the x's up here, and so we're left with a reduced fraction of 4x over 9. Now, this is something that we did when we were looking at our rules of exponents, and this is something that we were very comfortable with. So we're going to have to look at things like this and be able to do these, without too much difficulty. The one thing that we want to make sure that we're looking at is that you can only cancel factors. Now remember, factors are separated by multiplication in some way, but you cannot cancel terms. Well, terms are separated by addition. So anytime you see addition between two things, that means that those are both terms, and you can't just cancel out terms. You can only cancel when there's only multiplication. And so that's what we have to make sure that we're getting used to, where we're only canceling factors. And of course we're going to take a look at what those would entail. And so here's our example. So here are our ways that we can simplify algebraic expressions. And so one of the first ways that we do this is that we can look at the denominator and the numerator, and we can look at them kind of separately. And we can think about how they work individually, just like we've done with some other things. And so what we want to do first is that we want to factor out any kind of greatest common factors that we might see. Just like when we were working in day 1 and day 2, we were looking at factoring quadratic expressions and things like that, but we always looked for greatest common factors. So if we can remove greatest common factors to kind of help us simplify things, we're going to do that. And so we look at just the numerator first, and so we have 5x plus 10. Our greatest common factor between these two terms right here would be 5, so we have a greatest common factor of 5, and then we have left over x plus 2. So this is no different than some of the things that we were doing before. And then so we would do that same thing with the denominator. I see a 5x and a 50, and so that means that I have a common factor there of 5 as well. So I remove that 5 out here, and then I have x plus 10 on the bottom. Now the idea behind here is the way that I would simplify this is I look for things that are the same. So what I have that's the same here is that I don't necessarily just have numbers, so I have this 5 here and this 5 here. And then I have an x plus 2. We're treating that entire parentheses as one piece, and we're treating this x plus 10 as one piece. The difference here is this x and 10 are terms, but the entire thing is a factor because it's being separated by multiplication. And so I can factor polynomials if I need to using my A times C method, which we've been doing the last couple days. However, since this is just a single exponent of x, or what we call a linear term, we don't have to do anything with that, so we can just leave it as is. And so now I'm going to start to look at canceling similar factors. The similar factors that I have would be this 5 will cancel this 5. And so the idea there is I can reduce those as a fraction, so 5 over 5 is just 1. But x plus 2 and x plus 10 are going to stay because they are not exactly identical, and so I can only cancel things that are exactly identical. But I was trying to find whether the x plus 2 or the x plus 10 might cancel. The idea is what we want to look at is when we have our simplified form, it's x plus 2 divided by x plus 10. Now the one thing that I showed you on the last slide is we can't just cancel this 5x and this 5x. Those are canceling terms and we don't want to do that. And so the idea is that we only want to cancel factors. And so that's about as easy as simplifying algebraic expressions gets. So let's look at a couple of examples that require us to do a little bit more work. So the next thing I have are just basically two easy examples that are going to require us to do our first few steps. And so the first thing that we're going to do is, like I had said, is we're going to try to find a greatest common factor. And so like I said before, we can treat the numerator and the denominator kind of separately. And so in a way, what I can do is I can just kind of block this off for a little bit if I wanted to, and just kind of work with the x squared minus the 4x. And so obviously I'm going to look for a greatest common factor first. And so when I look at that numerator, I can find a greatest common factor of x in both of those terms. So I would have x on the outside, and then what I have left over, x minus. And so I've factored that numerator. And so the idea of what we're trying to look at is we're trying to find the most simplified version. So whenever you have a degree of 1 with any of your x's, you know that it's most likely in its simplest or its most factored form. And so now we can work with the denominator here. And so I'll put my fraction bar here to make sure that it's still there. And then I look for my common factor between 2x squared minus 8x, which in this case would be 2x, with what's left over of x minus 4 when I do here. Now the idea is that the second thing that I'm going to do is that if I needed to use my A times C method, I would, but I don't have any quadratics here, so there's no reason that I need to do this step. So I'll just go right to the third step, which is our canceling of our factors. Now the idea here is that we can only cancel factors, but they have to be identical to each other or reducing the degrees of our variables. And so the idea here is that x will cancel x, and so those two will cancel it out. Those are exactly the same. And this x minus 4 will also cancel this x minus 4. That set of parentheses, that factor, is identical, so it cancels out. So what I'm left with is I basically don't have anything on the top, so I just have to write a 1 over 2. So in essence, what this is saying is that this fraction right here, this x squared minus 4x over 2x squared minus 8x, will reduce to 1/2. Now on the other side of this, I can do the exact same thing here. So I'm going to go to this other example and find, again, greatest common factors to start. So I have 2x squared plus 16x. My greatest common factor there is going to be 2x. What I have left over is x plus 8. Okay, and then I can go to my denominator now. And so here I just have 4x squared, and so there's no other terms or anything like that that I can find greatest common factors in. And so I'm just going to leave this as 4x to the second. Now the idea behind this is that we have to be very careful with how we cancel things and how we kind of write things. So we really need to focus on our rules of our exponents and what actually will cancel itself out or cancel something else out. So as I go through here, I can start with my numbers, then I can start with my variables, and then I can start with my actual binomial factors. So 2 and 4 are my two numbers, and 2 and 4 have a common factor of 2. 2 goes into 2 one time, and 2 goes into 4 two times, and so that's how I can start to reduce those values. Now the next thing that I have is I have an x and I have an x squared. This x will cancel into this x one time, and then this will cancel out one of those, so I'm just left with an x on the bottom. So I'll just kind of get rid of that, and we have an x. And then the x plus 8 doesn't have anything that matches that, so we kind of just leave it as it is. And so our final answer here is 1 times x plus 8. So there's those two factors, divided by what's left on the denominator, which is 2 times x. So we're just looking at what can actually cancel and how we actually reduce, things that are not just numbers but also with variables with their different exponents, which if you're not sure about that, go back to our rules of exponents with division. Now the final example is going to require us to use all three of these rules, or all three of these steps. So the first thing is we're going to find if there is any kind of greatest common factor that we can remove. Sometimes we can have those greatest common factors, sometimes we don't. So we look at the numerator and we have x squared plus 3x minus 40. There's no common factors there. And then I can look at the denominator and I can say, okay, well, there is a common factor there. But to kind of avoid any kind of confusion, what we're going to try to do first is we're just going to try to work with the numerator and the denominator. Now our second step was to use our a times c, or the idea that we can factor quadratics. And so what we're going to do when we factor quadratics is that we're going to find those factor pairs that will combine to give you b. And so this is just like what we did with our factoring of quadratics. We just have to decide whether we need to use a times c, or whether our coefficient of our leading coefficient is 1, and then we can just jump right into finding factor pairs. This one, the coefficient is 1, and so we can just jump into our factor pairs, so that we're going to be looking at factor pairs of negative 40 that give us positive 3. That means that one is going to be positive, the other one is going to be negative. And then our two factors that multiply to give you 40, but then add up to give you 3 would be positive 8 and negative 5. And so that allows me to go right into my two factor pairs. And so I can say that this is x plus 8 as a binomial, and then x minus 5 as a binomial. And so there is my numerator. And so here I have 2x squared minus 10x, and so I can go through my same process, but this time I don't have to worry about doing a quadratic, because I can find a common factor there, which the common factor is 2x, so it eliminates that need for the quadratic factoring. And then I have x minus 5 in the denominator. And so now that I have everything factored, so all of these factors are linear, meaning that they're all degree 1, and that's kind of what I was shooting for. The next thing that I can do is I can start to cancel similar factors. And so the factors that are identical to each other, I can start canceling them. And so I have an x plus 8 and an x minus 5 on the top, and a 2x and an x minus 5 on the bottom. So that means that the x minus 5 and the x minus 5 will cancel each other. Those are exactly identical. I cancel the entire thing, not just a piece of it. And there's nothing else that cancels, and so my final answer here is just going to be x plus 8 divided by 2x on the bottom. Now there's nothing else that I can cancel. This x plus 8 needs to be treated as an entire thing, and so I can't cancel these two x's in the numerator and the denominator, because they have to be exactly identical to each other. And so that's basically our general thought on how we can simplify rational expressions. We're going to work on a little bit more of these, and then we're going to look at one other aspect of these that we also have to pay attention to.